All right, today we're going to talk about radians and degrees. So radian is just a new way of looking at angle measures, and you've always worked with degrees before, but now we're going to talk about radians, and this is what a lot of advanced mathematics uses when they're measuring angles. So it's going to be kind of a shift in thinking to get out of the mindset of degrees and into the mindset of radians, but we're going to explain what a radian is, and then we're going to talk about how we convert from degrees to radians. So a radian is the measure of a central angle that intercepts or subtends, that's just another word for intercepts, an arc that is equal in length to the radius of the circle. So let me show you what I mean. If this circle has a radius of 1 inch and the length of this arc, if the length of that arc is 1 inch, this angle is your theta, and that theta is equal to 1 over 1, or that would be 1 radian. Similarly, if this is 1 inch and my angle is here, so let's say this is 1 inch and then this is another inch, so that arc length is 2 inches, right? Then we would say that this is our theta, and theta is 2 over 1, or 2 radians. So I'm just abbreviating radians with just RAD here. Okay, and then similarly, right, if this is 1 inch, this right here, and I didn't draw that very straight, so it's not quite a straight line. But this is theta, so this is 1, here's 2, and here's 3, so this is 3 inches. Then we would say theta is 3 over 1, or 3 radians. Okay, so what we say is to find that central angle, we use this formula, theta equals S over R. S is your arc length, and R is your radius. Okay, so it says find the radius of a circle in which a central angle of 1.5 radians intercepts an arc of 15 inches. So if we use that formula, theta is equal to S over R. It says find the radius. The central angle is 1.5 and the arc is 15, and we're trying to find R. Right, so we've got 1.5, R is equal to 15, so R ends up being 15 divided by 1.5, and that gives us 10. So our radius is 10 inches. Similarly, over here, theta equals S over R. Find the number of radians in a central angle. So here we're looking for theta. If the radius of the circle is 4, and the intercepted arc is 5, and those are both in centimeters, so we would say theta is 1.25 radians, or you could leave it as 5/4 radians, either one. When we are talking about a central angle and we're using this formula can only be used if our angle is in radians. So for example, if you were given this first problem and they gave you the angle in degrees, we would not be able to use the formula. We have to convert the formula into radians because this ratio is specific to radians. We're going to talk about how you convert between radians and degrees. Okay, one other thing I want to point out here is this angle, it's not quite a straight line. This angle is just shy. This angle right here is just shy of being a straight line, and that gave us 3 radians. However, if this angle was a straight line, this angle was a straight line, right? Would be kind of something like that. Something sort of like this. I didn't draw that very well, but you get the idea there. Right? It's just a little bit more, right, than 3. Well, what number is a little bit more than 3? Well, pi, right? Pi is approximately 3.14. And in fact, if we did a more lengthy investigation of this, we would find that pi is exactly halfway around the, pi would be that straight line, which would basically give us halfway around the circle. And so we have a conversion factor that we'll be able to use that says, well, halfway around the circle is 180 degrees. But if I did this ratio of 3.14 over 1, that would give me pi. And so that would make that central angle pi radians. And so we have this conversion factor that says 180 degrees is equal to pi radians. That is something that is going to be extremely useful to us when we are converting between degrees and radians. Now, eventually you're going to learn how to think in radians, right? You're going to get out of the mindset of thinking in degrees and then converting into radians. We'll get there, but for now, it's important that you know this, that 180 degrees is in fact pi radians. Remember, radian is just the relationship between the arc length and the radius of a circle. Okay, I'm going to stop the video here. In the second video, you'll see a more extensive investigation of radians versus degrees.